When we think about space, the first thing that often comes to mind is the vast, infinite universe full of twinkling stars. On Earth, our night sky is dotted with countless points of light, offering a magnificent view as they sparkle across the darkened canvas of the heavens. We've all been captivated by the beauty of a starry sky, whether it's a familiar constellation or the occasional shooting star, and these celestial lights have inspired awe for millennia. However, what happens when we move beyond Earth and venture into space? The answer may surprise you, and it's a question that has puzzled astronauts, scientists, and space enthusiasts for decades. Imagine yourself floating in the infinite void of space. You are weightless, drifting in the dark emptiness, surrounded by the breathtaking and shimmering band of the Milky Way, stretching across the cosmos. It's a view like no other, one that only a select few have experienced firsthand. But there's something strange that catches your eye as you gaze through the visor of your helmet. The stars, which you've always seen scattered across the sky on Earth, are nowhere to be found. The night sky is pitch black, devoid of those brilliant points of light you would expect to see from such a vast, unshielded view of the universe. The absence of stars in the sky when looking out from space seems contradictory. After all, space is far less obstructed than Earth's atmosphere. One might assume that seeing the stars should be even easier in space than on Earth, where light pollution, atmospheric scattering, and weather conditions often obscure our view. If space is truly a vacuum, free from the refractive effects of Earth's atmosphere, why can't we see the stars clearly in space? This paradox, this missing stars phenomenon, has intrigued scientists and astronauts alike for many years. It's an enigma that touches on fundamental aspects of physics, human perception, and the limitations of technology. Some of the most iconic images of human space exploration, such as those captured during the Apollo missions, show astronauts standing on the lunar surface, proudly planting flags or leaving footprints. These images are etched into the history of space exploration, but they also leave one key question unanswered: where are the stars? This puzzle became more widely discussed when doubts about the authenticity of the moon landing surfaced, and conspiracy theorists pointed to the absence of stars as supposed evidence of a hoax. Despite all the attention this missing stars phenomenon has received, the answer is far simpler than many might think. The absence of stars in photos taken by astronauts on the moon, or even when astronauts venture into space, is not evidence of anything nefarious. Rather, it's an outcome of basic physics and human perception. To understand why, we need to take a deep dive into the mechanics of light, vision, and how cameras work both on Earth and in space. Let's start by considering the Apollo 11 mission, one of the most well-known examples of space exploration. The Apollo 11 mission marked the first time humans set foot on the moon. Neil Armstrong, Buzz Aldrin, and Michael Collins were not only pioneers of human space travel but also some of the first to experience the oddity of the missing stars firsthand. When looking at the famous photos from the Apollo missions, it becomes immediately apparent that there are no stars visible in the background. One of the most famous images shows Buzz Aldrin standing next to the American flag on the moon's surface. But aside from the astronaut and the flag, the background is an empty, black expanse. Similarly, another iconic image from the mission shows Neil Armstrong's first footprint on the lunar surface. The fine details of the lunar dust are beautifully captured, but once again, the stars are nowhere to be seen. In the 1960s, when the Apollo 11 mission took place, the absence of stars in these photos was not a widely discussed topic. In fact, it wasn't until the rise of conspiracy theories surrounding the moon landing that people began to notice the missing stars and question why they weren't visible. Some speculated that the lack of stars in the photos could be evidence of a staged moon landing, while others simply found it puzzling that the stars were nowhere to be found. So, why didn't the cameras capture any stars? The answer lies in the way light works in space, and how both human eyes and cameras respond to varying light levels. It's not that the stars weren't there, but rather that the conditions in space made it incredibly difficult to capture their faint light in the photos taken on the moon. When astronauts were on the moon, they were in direct sunlight, which is extremely bright. The moon itself reflects this sunlight, making the lunar surface even brighter. In such conditions, the human eye and cameras must adjust to avoid overexposure. In photography, there are three primary factors that determine how an image is captured: exposure, aperture, and shutter speed. These elements work together to control the amount of light that reaches the camera's sensor. A smaller aperture, the opening in the lens through which light enters, lets in less light, and a faster shutter speed, how long the camera's sensor is exposed to light, prevents the image from becoming too bright. On the moon, astronauts were exposed to the full force of the sun's rays, which meant that the lunar surface was incredibly bright. To capture the details of the lunar surface without overexposing the image, the cameras had to be set with a relatively small aperture and a fast shutter speed. These settings were ideal for capturing sharp details of the astronauts and the moon's surface. However, the stars, being much fainter, could not be captured with these settings. They simply didn't provide enough light to register on the photos when exposed to such bright sunlight. If the camera had been set with a longer exposure time to capture the stars, the moon's surface would have been completely overexposed, turning it into a white, featureless blur. The absence of stars wasn't just an issue for the Apollo missions. In fact, it's a common experience for astronauts who venture into space. Whether they are orbiting Earth or venturing to the moon, astronauts have all noted the strange effect of looking out into space and seeing nothing but the black void. They have often reported that while the stars are visible at certain moments, they disappear when the spacecraft is in sunlight or when they are looking at bright objects like the moon's surface or Earth itself. Astronauts who travel to the International Space Station, ISS, experience this phenomenon several times a day as the station enters and exits the Earth's shadow. When the ISS is in the Earth's shadow, the lighting conditions are much darker, allowing the faint stars to become visible once more. But as soon as the ISS emerges into sunlight, the brightness of the sun washes out the stars again, and they disappear from view. This effect has everything to do with human vision. Our eyes are designed to adapt to the lighting conditions on Earth, where we are constantly adjusting to the changing light levels throughout the day. In space, however, our eyes face a much more challenging environment. When astronauts are exposed to the bright sunlight, their pupils constrict to limit the amount of light that enters the eye. This helps protect their vision from the intense glare of the sun, but it also makes it much harder to see faint light sources like stars. The stars are simply too dim to be seen when the sun's light is so overpowering. But when astronauts enter a darker region, such as when they pass into the Earth's shadow, their eyes adapt to the darkness, and they are able to see the stars once again. The same principle applies to cameras, which are not immune to the challenges posed by the extreme lighting conditions in space. Early space photography, like that captured during the Apollo missions, relied on relatively simple camera technology. The equipment was designed to capture high-quality images of the astronauts and the lunar surface, but it wasn't capable of capturing both the bright moon and the distant stars simultaneously. The technology of the time was simply not advanced enough to handle such a complex task. Since the Apollo missions, space photography has come a long way. Modern astronauts have access to state-of-the-art digital cameras and even smartphones, which are capable of capturing much more detail and color than the film-based cameras used in the past. With these advancements in technology, it's now possible to take stunning photos of the Earth from space, as well as images of distant celestial bodies. The development of specialized equipment, such as the cameras used on space telescopes like Hubble and the James Webb Space Telescope, has allowed us to peer deeper into the universe than ever before. These telescopes have provided us with breathtaking images of distant galaxies, nebulae, and stars, revealing the true splendor of the cosmos in ways that were previously unimaginable. With advancements in technology, space photography has become far more accessible and capable. Cameras on the ISS allow for stunning images of our planet and the cosmos. The live-streamed views from the station offer a unique perspective of the Earth, complete with views of auroras, city lights, and the majestic movement of stars as the ISS orbits our planet. As technology continues to advance, space photography will only get better, providing us with clearer, sharper, and more colorful images of the universe than ever before. The ability to see and capture the stars in space has also been improved by the development of modern imaging techniques such as high dynamic range, HDR, photography. This technique allows for the combination of multiple images taken at different exposures, which can help capture both bright and faint objects in the same shot without overexposing or underexposing any part of the image. However, these techniques were not available to the astronauts during the Apollo missions, which is why their photos of the moon lacked visible stars. In the future, when astronauts once again set foot on the lunar surface, we can expect to see photos that better capture the stars in space. With advancements in space technology and photography, we'll be able to experience the cosmos in all its glory, as astronauts use more sophisticated equipment and techniques to document their journey. The upcoming Artemis missions, which are set to return humans to the moon, will likely provide us with some of the most stunning images of space and the lunar surface to date. While the absence of stars in space may have been a mystery in the early days of space exploration, today we have a much clearer understanding of the phenomenon. It's a combination of human perception, the limitations of early space photography, and the challenges posed by the extreme lighting conditions in space. The stars, while always present in the background, are simply too faint to be seen when compared to the intense brightness of sunlight and the moon's surface. But as technology continues to evolve, we can look forward to clearer and more spectacular images of the stars, planets, and galaxies that surround us in the vastness of space.